All right, so today we are talking about Chapter 5, and we're doing Lessons 6 and 7, which is add and subtract linear expressions. Now, a linear expression is an algebraic expression in which the variable is raised to the first power, and the variables are not multiplied or divided. So here is the table below gives some examples of expressions that are linear and some examples of expressions that are not linear. So if you look at the linear expressions, you'll see that all of these variables are to the first power. They don't have an exponent other than 1. Here on the other side, you can see that the exponents 3 and 4. So those are not linear, okay? Also, variables are not multiplied or divided. So here, those variables are multiplied, so that is not a linear expression. So we are going to add and subtract linear expressions. So you can add using models here. And when we add or subtract linear expressions, all we're doing is we're putting our like terms together. We're combining like terms, keeping in mind that the operation is also the sign of the number that follows. Okay, so here in example 1, using the models, we have the quantity of 2x plus 3 plus the quantity x plus 4. So 2x, you can see the picture, 2 green X boxes, okay? And then the ones, the constants, are represented by the little yellow squares. Okay, so we have those. And then on this side, we have the X plus 4. So there's 1 X and there's 4 ones. So when we're adding them together, we just put all the X's together. And we put all the ones together. Does everybody see that? So we're going to end up with 1, 2, 3x. So there's the 3x. And 1, 2, 3, 4, 5, 6, 7 ones. So quantity x squared plus 3x plus the quantity x plus 4 is equal to 3x plus 7. For subtraction, it's the same thing, except we're just taking things away. So here, if we have the quantity of 6x plus 3 minus the quantity 2x minus 2, here, this is the whole thing is a 6x plus 3. We're taking away 2 of the x's and 2 of the 1's. And that's what it looks like in the model when we take away 2 of the x's and 2 of the 1's. And what's left is 4 of the x's and 1 of the 1's. So this expression simplifies to 4x plus 1. So for example 2, now here we're doing this without models. We have 2x minus 1 plus the quantity x minus 5. Now, please write this down right here. If the number in front of the parentheses is 1, then you can just remove the parentheses and then combine like terms from there. Okay? Now, when I say the number in front of the variable is 1, does everybody see here? This says plus the quantity x minus 5. There's no number in front of the parentheses, so that means this is going to be 1. Once we take the parentheses away, we have 2x minus 1 plus x minus 5. Okay? And then you can combine your like terms. So we have a 2x plus x plus 1x, and that's going to give me a 3x. And then we have negative 1 plus a negative 5, and that's going to give me a negative 6. Now for subtraction, it's a little different. We still have a 1 in front of the parentheses, but this time, what kind of 1 is it? It's a negative 1. So here, the number in front of the parentheses must be distributed throughout the parentheses. So here, we have to use the distributive property to put that negative 1 into the parentheses. So here, this is going to be a negative 1 times x, which gives me a negative x. Does everybody see that? And then we have negative 1 times negative 2, which gives me a positive 2. So once we have distributed that negative 1 throughout the parentheses, then we can combine our like terms. So 2x minus 1x is equal to 1x, or just x. And then negative 3 plus 2 gives me a negative 1. So for the got it's, let's look at example A. Problem A. We have the quantity of 3x plus 5 plus the quantity 2x plus 3. Now here, it's all addition, right? So that means that I can go ahead and take the parentheses away. Okay? So when I rewrite this, we end up with 3x plus 5 plus 2x plus 3. Now, I want to show you that the reason why we can just take the parentheses away is if there was, see there's no number in front of the parentheses? So what number is actually in front of the parentheses? 1. So if I'm going, and that's a positive 1, right? So if I distribute this positive 1 throughout the parentheses, this is going to be 1 times 2x is 2x. You see that? And then we have 1 times 3, which is positive 3. Does everybody see the reason why we can just take away the parentheses? So now we can go ahead and combine our like terms. Okay? So we've got, I'm going to use colors here. We've got the 3x and the positive 2x. And we've got the positive 5 and the positive 3. So when we combine our like terms, 3x plus 2x is 5x. And a positive 5 plus 3 is positive 8. All right. So for the quantity of 2x minus 4 plus the quantity of 3x minus 7, we can just take away the parentheses, right? So once we take away the parentheses, we end up with 2x minus 4 plus 3x minus 7. And then when we combine our like terms, we have the 2x plus a 3x, that's 5x, and then negative 4 plus a negative 7 gives me a negative 11. All right, so now let's look at the subtraction. Now, once again, when we're looking at subtracting linear expressions, we want to first distribute this negative 1 throughout the parentheses. Okay? So when we distribute that negative 1, we end up, let's see, over here we can just take the parentheses away here, right? Because there's a positive 1 in front of this parentheses, right? So we can just take that parentheses away. So that's going to be 5x minus 9. And now we're going to distribute. Negative 1 times 2x is negative 2x. And then negative 1 times negative 7 is positive 7. And now we can combine our like terms. So we can put the 5x and the negative 2x together. And we can put the negative 9 and the positive 7 together. So 5x minus 2x is 3x. And then negative 9 plus 7 is negative 2. All right, so once again, we have a negative 1 because we're subtracting. So we have a negative 1 in front of the second set of parentheses. So negative 1 times a positive 2x gives me a negative 2x. And then negative 1 times a negative 8 gives me a positive 8. So now when I combine my like terms, I have 6x minus 2x, or 6x plus a negative 2x. That's going to give me 4x. And then I have negative 10 plus 8, which gives me negative 2. All right, so what's different about these is that now, rather than having just take away the parentheses, you can see that you would have to use the distributive property here first. Does everybody see that? Okay, so for the example 4, you have 2 times the quantity x plus 3 plus 3x, the quantity 3x plus 1. So once you distribute, 2 times x is 2x, and 2 times 3 is positive 6. So now this is the expression that we're going to simplify. And now it's just 2 quantities, and we're adding them, so we can just go ahead and take the parentheses away. And then when we do that, now we combine our like terms, the x values and the constants, and we end up with 5x plus 1. So the only difference here is that, once again, we're going to take the number on the outside of the parentheses, and we're going to distribute it into the parentheses, just like we did with the subtraction, but this is in with the addition. Is everybody clear with that? Now, on the other side, this is, now we're looking at negatives and negatives. So here, for the first example, we are going to distribute the negative 1 throughout the parentheses. This one is not different at all. So we're going to multiply negative 1 times 3, that's negative 3x. And then negative 1 times a positive 1, that gives me negative 1. And then we combine our like terms like we did in the previous examples. Down here, for example 5, we have no number in front of the first quantity, so we can go ahead and just take those parentheses away. So this is going to be negative 4x minus 7. On the second quantity, you have a negative 1 in front of the parentheses, so you need to use the distributive property to take the parentheses away. So here we have negative 1 times a negative 5x, and that's going to give me a positive 5x. And then we have a negative 1 times a negative 2, and this is just going to give us a positive 2. And then once you have simplified all the parentheses out, now you can just combine your like terms, just like the previous examples. Okay, so let's do these examples here. Now, remember, if the number in front of the parentheses is 1, then you can just remove the parentheses. If it is something other than a 1, a positive 1, then you have to distribute first. Okay? Same thing with the subtraction. Okay? So, for example E, we have 6 times the quantity x plus 7 plus the quantity x plus 3. So in this example, we're going to distribute the 6 throughout the parentheses. Okay? So we end up with 6 times x is 6x. And then we have 6 times a positive 7 is a positive 42. You see how I said positive in there? Plus, now here we can just take the parentheses away because we have a positive 1 in front of the parentheses. Does everybody see that? So this is just going to be plus x plus 3. And now I can combine my like terms. So we have 6x plus x, and we have positive 42 plus 3. So 6x plus x is 7x. Very good, because what's in front of this x right here? A 1. A 1 is in front of it. So this is 6x plus 1x, that's 7x. And then we have 42 plus 3 is a positive 45. Got it? All right. So how about you guys do example F on your own? Oops. Very good. So here you're going to, we can just go ahead and take the parentheses away from the first quantity because that's just a positive 1 in front of that. So we take that away. We got 12x plus 19. Then over here we have a 2 in front of the parentheses. So we need to distribute first. So we have positive 2 times x, that's positive 2x, and positive 2 times negative 10 gives me a negative 20. So then we combine our like terms, and we end up with 14x minus 1. All right, so let's do some subtractions. So once again, when you have a negative 1 in front of the parentheses, you have to distribute throughout the parentheses before you start combining like terms. Now, just as a reminder, when you perform the distributive property, there are no more parentheses. Is everybody clear with that? Okay, once you distribute, no more parentheses. So, for this first one, we can go ahead, because it's a positive 1 in front of this parentheses, we can just take those parentheses away. So we end up with 4x minus 3. Then over here, we've got a negative 1 in front of the parentheses, so we have to distribute. So we're going to distribute the negative 1 into the parentheses. So negative 1 times 2x is negative 2x. And then negative 1 times a positive 7 gives me a negative 7. And once again, we can combine our like terms. Now please notice that when I am circling and putting boxes around each of the terms, I'm including the operation. Because once again, the operation is also the sign of the number that follows. You got it? All right. So when we simplify this, we have 4x minus 2x, which gives us 2x. And then over here we have negative 3 minus 7, or plus a negative 7, and that gives me negative 10. All right, so let's do example D together for the subtraction. So here, once again, there is a positive 1 in front of this parentheses, so we can go ahead and take those parentheses away. So we have 4x minus 4. And then over here, we have a negative 1 in front of the parentheses. So this one, we're going to have to use the distributive property. Okay? So when we do that, we have negative 1 times negative 2x is a positive 2x. And then we have a negative 1 times a positive 2, and that's going to give me negative 2. Very good. So now we can combine our like terms. So we've got a 4x and we've got a positive 2x. And we have a negative 4 and a negative 2. And now we can combine our like terms. So 4x plus 2x is 6x. And negative 4 plus a negative 2 is negative 6. All right, so for here, we're going to distribute the negative 1 throughout the parentheses, and we can take the first parentheses, the set of parentheses away, because there's just a positive 1 in front of that parentheses. So we have 3x minus 2, and then negative 1 times positive 5x is a negative 5x, and a negative 1 times a negative 4 is a positive 4. So here, we're going to combine our like terms. So we have 3x minus 5x, or 3x plus a negative 5x. That's going to give us a negative 2x. And then negative 2 plus 4 gives us, oopsie, positive 2. Positive 2. Good catch. Good catch. All right. Is everybody good? All right, so let's do this one over here together, since some of you did this one. So here we have x minus 1, quantity x minus 1, plus the quantity 2x plus 3. Now on this example, all the numbers in front of the parentheses are positive 1s. So that means you can just take the parentheses away, right? All right. So here we're going to have an x minus 1 plus 2x plus 3. So now when we combine our like terms, let me just point them out to you. We have the x and a positive 2x. And we have a negative 1 and we have a positive 3. So when we put those together, x plus 2x, of course, is 3x. And negative 1 plus 3 is a positive 2. All right, so for example D, this one's a little different because here, even though it's plus, we're adding two quantities, and the number in front of the parentheses is still a positive 1, look at what happens here. We have plus a negative. Is everybody with me on that? Okay, so keep that in mind when we're rewriting our problem. So here we have, there's just a positive 1 here, so we can take that away. So that's x minus 4. Okay, now here, this is a positive 1 in front of this parentheses, right? So here, I'm just going to go through the motions of the distributive property so you can see what happens, okay? So we've got a positive 1 times a negative 2x, which is what? Positive times a negative is a negative, right? So positive 1 times a negative 2x is a negative 2x. You see that? And then over here, this is going to be a positive 1 times a positive 1, of course, is just plus 1. Now, the reason I say this is different is because if I were just taking the parentheses away, I would end up with, oops, take the parentheses away, x minus 4 plus a negative 2x plus 1. Does everybody see that? So here, remember we talked about this? Well, not that whole highlight. Just this part right here. When we have plus a negative means subtract. So now we can go ahead and start combining our like terms. So we've got a positive x and a negative 2x. And we've got a negative 4 and a positive 1. So x plus a negative 2x. This is 1x plus a negative 2x. What's 1 minus 2? All right, so here we have 1x minus 2x. So 1 minus 2 is a negative 1. So this is going to be a negative 1x. Is everybody with me? So this is going to be negative 1x. Okay? And then we have negative 4 plus 1, which is a negative 3. Now, normally, we're not going to write a negative 1 in front of the variable, right? You're not going to write the 1. So here, we've got negative 1. Can I just write this as a negative x? Is everybody clear? So negative x minus 3. Is everybody clear? All right, so this last example, one subtraction and one addition and one subtraction. The example 6 for addition is just like finding the perimeter on your homework from last night's homework. The only difference here is that we are adding linear expressions rather than just algebraic expressions. Okay, so here it says, write a linear expression in simplest form to represent the perimeter of the triangle. And then we want to find the perimeter if the value of x is equal to 5 centimeters. So perimeter is just the adding up the whole distance around, right? So here we're going to add 3x minus 3 plus 2x plus 9 plus 5x. You got that? Okay? So here's what it looks like when you write it out with parentheses. Now, they all have a 1 in front of the parentheses, a positive 1, right? So I can just take the parentheses away. So once I do that, then I can combine my like terms. So 3x plus 2x is 5x, plus 5x is 10x, and then negative 3 plus a positive 9 is a positive 6. So this is the expression that gives me the perimeter of this triangle. So then the second part of this problem says, find the perimeter of the value of x if x is equal to 5 centimeters. So there you're going to evaluate that expression when x is equal to 5. So you're going to substitute and simplify. So for the last example, this one is for the subtraction. It says, a hat store tracks the sale of college and professional team hats for M months. The number of college hats sold is represented by the quantity 6M plus 3. The number of professional hats sold is represented by the quantity 5M minus 2. Write an expression to show how many more college hats were sold than professional hats. Now, you know what this means. How many more? You know that that means this is going to be a subtraction problem, right? So, we are comparing college hats to professional hats. Okay, so how many more college hats than professional hats? So it's going to be the college hats minus the professional hats. Is everybody clear with that? So for the college hats, that's 6M plus 3, and then we're going to subtract the professional hats, which is 5M minus 2. Now, once again, before we combine our like terms, we have a negative 1 in front of that parentheses. So that needs to get distributed throughout the parentheses. So once we do that, then we can combine our like terms, and the expression is M plus 5. Then it says, evaluate the expression if M is equal to 10. So here, now we're going to substitute 10 in for M, and then simplify. Substitute and simplify. So that tells me that 15 more college team hats were sold than the professional hats.